As we talk about linear functions, there's one special type of linear function that can arise, and a function where there's actually no initial value, right? Or at least it's visible, no initial value that's visible. And that just means that the initial value would be zero. It starts at 0, 0. Okay. In these cases, we just say that, well, I mean, quite literally, we just get that y is equal to mx, or that's just saying that to get y, we take a multiple of x and we're done, right? And so when that happens, y is actually proportional to x, okay? You could, if you wanted to, you could actually rearrange this. So if y equals mx, um, m times x, you could rearrange that and say that y over x is this constant m, okay? That's another way of saying that. And if you think about that, if we had changes in there, isn't that just the slope equation? So this all makes sense. It's consistent with what we know about linear functions, okay? But this language of proportional might be a little new to us, and also you might encounter language that says varies directly as, or it is in direct variation. Those things mean the same thing. And again, all that language means is that y is equal to k times x. And again, we're just using a general k here to mean the constant of proportionality. And really this k functions the same as our slope m, if I can write that out correctly. So if we're being asked about constant proportionality in a linear function context, that's just our slope, okay? But again, you have to have no initial value. Initial value has to be 0, okay? So just a quick check here. We're thinking about circumference of a circle, and is that proportional to its diameter? So how do I calculate the circumference of a circle? Well, we might remember that this is 2 pi r, right? Or more generally, if you kind of rearrange, this would be pi times 2r, right? And 2r, 2 radii, is equal to a diameter. Okay, so we want to know, is this proportional? Is circumference proportional to diameter? Is circumference equal to a multiple of the diameter? Yeah, in fact it is. It is. And the constant of proportionality is pi. So yes, k is equal to pi. All right. So look for those proportional situations where you have, a linear relationship, an exponent of 1 on each unknown variable, and then one of them has to be multiplied by a constant. Okay. So now maybe a more difficult example is constructing the model. Okay, so this one talks about volume of a person's blood in a body varies directly as their body weight. Okay, and just to introduce notation, so we have volume of blood in a person's body, okay? I'm going to call that V, and then varies directly as, that's that language of proportionality, same idea. And then body weight, I'm going to say that this is W, okay? So the base equation here is going to be V is equal to a multiple, K times, W, okay? Because we're saying it varies directly as, right? Y varies directly as X. So look for that little bit of language, and then your variables are defined there, okay? So now, let's see, so then there's some information given. Oh, we're not done yet, okay. A person who weighs 160 pounds has approximately 5 quarts of blood. Okay, so then what is that telling me? So that's a weight, so I can put that in for W, and then 5 quarts of blood, that's a volume. Oh, I can figure out what K is. Oh, okay. Yeah, and actually, in general, just like we saw in the circumference equation, we want to know what that constant of proportionality is. We want to figure out what it is. So if I do this, divide both sides by 160, okay, that just gives me that K is 1 over 32. So really, my equation is actually V is equal to 1 over 32 times weight W, okay? But the prompt doesn't end there. Okay, we need to keep on doing more stuff. And it says, so estimate the volume, the number of quarts of blood for a person who weighs 200 pounds. Okay, so then I can go ahead and say, okay, well, I want to know what V is, right? Number of quarts of blood, that's V, is unknown. And then for this particular individual, they weigh 200 pounds. And so if I do the calculation, let's see, I get that volume is 6.25, okay? Or 25/4, whichever you prefer. So now am I done? Yeah, pretty much. I just need to write my answer in sentence form because we're in a context. So I'm going to say that the number of quarts of blood for a 200-pound person is 6.25. I could say I already have quarts defined in there, so that's enough. All right, there we go. So big takeaways, okay? When we talk about linear functions, we can narrow our scope to just linear functions where there's no initial value or initial value is 0. And in that case, we get proportionality coming out. When we talk about proportional statements, the slope is our constant of proportionality. Okay, so we need to look for that constant of proportionality popping up. And so we need to be able to say, is there proportionality going on? Yes or no? And then also, if we know there is, we have to be able to construct the model. Okay, so construct the function and use it.